Hi everyone, welcome back to my YouTube channel. I'm Mahlaku Patricia. Today we're diving into the world of calculus and exploring integration. Whether you're a student looking for a help or just love mathematics, this video is for you. Okay, let's get started with the integration and break it down step by step. The integration is the method of finding the area under a curve or accumulating quantities. It's essentially the reverse process of differentiation. In real life, integration is used to calculate area, volume, center of a mass, and to model various physical and the real-world phenomena. Connection between integration and differentiation. Differentiation and integration are the inverse operation in calculus. Differentiation finds the rate of the function, while the integration finds the accumulation of a function. The lesson goal: by the end of the lesson, we must be able to define integration and its purpose, explain the connection between integration and differentiation, lastly apply integration in real life. Let's start with our first example. We're given y equals to e raised to power x power 1 over 2 all over x to the power 3. Since we're dealing with integration, we're going to put the integral sign. Then we have e to the power x power 1 over 2 times 1 over x to the power 3 with respect to x. Then our next step will be the integral of e to the power x. Then we change 1 over 2, we write a minus 2 times, then we change 1 over x to the power 3, then we write it as the x raised to the power minus 3 with respect to the x. We use the u substitution to solve this. Then our u will be equals to x to the power minus 2. Then when we differentiate x to the power minus 2, then our du will be equals to minus 2 x to the power minus 3 dx. Then we're going to divide both sides by minus 2. Then we have a du over negative 2 equals to x to the power minus 3 dx. Then our next step will be the integral of e. Then where there is x to the power minus 2, we're going to replace it with u. And where there is x to the power 3 times dx, we're going to replace it with du over negative 2. Then we take the constant negative 2, move it to the front. We're going to have the negative 1 over 2, the integral of e to the power u du. Then we're going to integrate e to the power u. Then we'll have the negative 1 over 2 e to the power u plus c. Then from here we're going to substitute u with x raised to the power minus 2. Then our final answer will be negative 1 over 2 e to the power x minus 2 plus c. That is our final answer. Our next example is y equals to 1 over the square root of 3 minus 2x. Then we write it as the integral of 1 over the square root of 3 minus 2x with respect to x. Then we use the u substitution method to solve. Our u will be equals to 3 minus 2x. Then we differentiate 3 minus 2x. du will be equals to negative 2 times dx. To make the x the subject of the formula, we divide both sides by negative 2. Then we'll be left with du over negative 2 is equals to dx. Then from here we have the integral of 1 over the square root of u. Where there is 3 minus 2x, then we replace it with u. Where there is dx, we replace it with du over negative 2. Then we take the constant negative 2 and move it in front of the integral sign. Then from here we have the negative 1 over 2, the integral of u raised to the power negative 1 over 2. 1 over the square root of u can be written as u raised to the power negative 1 over 2 times du. Then from here we integrate u raised to the power negative 1 over 2. Then we have the negative 1 over 2 times u raised to the power 1 over 2 over 1 over 2 plus c. 1 over 2 will cancel with 1 over 2, then we'll be left with the negative u raised to the power 1 over 2 plus c. Then we all know 1 over 2 is same as the square root of root 2. Then our final answer will be equals to the negative square root of u will be replaced with 3 minus 2x. Then we have the square root of 3 minus 2x plus c. This is our final answer. Now we are dealing with the integration by parts. We are given y equals to x cos 3x. Since we are dealing with the integration, we include the integral sign, then we have the integral x cos 3x with respect to the x. When dealing with integration by parts, we use the formula the integral u dv is equals to u v minus the integral of v du. Then we use the light method. The light method help us to choose u and v in the integration by parts. And L is then for logarithm, I for inverse, and A algebraic function, T trigonometry, and E exponential function. So x is a and cos 3x is t. Since a comes before t, our u will be equals to x and dv will be equals to cos 3x. Then from here we use the tabular method because the tabular method make it easier to apply in the formula. Then we use the SDI. So for S is for alternative sign, then we have a positive, negative, positive, and so forth. Our u is equals to x. When we differentiate x, we obtain 1. Then we differentiate what we obtain, we get 0. Then since we got 0, then we stop here. Then we go to the integration. Then from dv is equals to cos 3x. Then when we integrate cos 3x, we get the positive sign 3x over 3. Then when we integrate what we have, we get the negative cos 3x over 9. Then from here, we're gonna get our first term by multiplying each term diagonally, then and apply the alternative sign. Then our first term will be equals to x assign 3x over 3. Then our next term will be positive cos 3x. Since we have the negative sign and the negative sign there, then multiply each other, it gives us the positive. Then we have the cos 3x over 9. Okay, then from here we're gonna apply everything we got into our formula. Then we have the integral of x cos 3x dx will be equals to 1 over 3 times x times sine 3x plus 1 over 9 times cos 3x plus c. This is our final answer. Our next example, we have y equals to e to the power x sine 3x. Then we include the integral sign. We have the integral of e to the power x sine 3x with respect to x. Then from here we use the light method, so t comes before e. Then our u will be equals to sine 3x. and dv will be equals to e to the power x. Even here we still use the tabular method. Then we have our sign, positive, negative, and positive, and so forth. Then our u is equals to sine 3x. When we differentiate sine 3x, we get the positive 3 cos 3x. Then when we differentiate the 3 cos 3x, then we get the negative 9 sine 3x. Then our dv is equals to e to the power x. When we integrate e to the power x, we have e to the power x. When we integrate what we obtain, we have e to the power x. Then since we obtained the common function as the first row, we're gonna stop here. Then from here we're gonna multiply diagonally to get our first terms. Okay, then our first term will be equals to e to the power x, the sine of 3x, since we have positive signs. Then okay, our next term will be equals to negative e to the power x times 3 cos 3x. On our alternative sign, we have negative sign, then we have a positive sign, then we have a positive sign on e to the power x, so it gives us the negative sign. Then from here we just plug everything into our formula. Then we're gonna have the integral of e to the power x sine 3x dx is equals to e to the power x sine 3x minus e to the power x times 3 cos 3 of x. None of the function in the last row is equals to 0, which means we have the integral value. Our integral value is equals to, our integral value is negative the integral of 9 sine e to the power x sine 3x dx. Then from here, let's rewrite our function and bring the integral on the other side. Okay, we have the negative sign here. When it goes to the other side, it becomes positive. Then the coefficient of the integral e to the power x sine 3x dx is 1. Then 1 plus 9, it gives us 10. The integral of e to the power x sine 3x dx will be equals to e to the power x sine 3x minus e to the power x times 3 cos 3x. Then from here we divide both sides by 10. Then we'll be left with the integral of e to the power x sine 3x dx will be equals to 1 over 10 into e to the power x sine 3x minus e to the power x 3 cos 3x close brackets. And from here we have a common factor of e to the power x. Then we're gonna take it outside the bracket. Then we'll be left with 1 over 10 times e to the power x into sine 3x minus 3 cos 3x close brackets plus c. This is our final answer. Let's take a look at our last example. We are given y equals to e to the power 2x sine x. Then we include our integral sign. We have the integral of e to the power 2x sine x with respect to x. Then our u is equals to sine x. dv is equals to e to the power 2x. Then even here we use a tabular method. Then we have our alternative sign, positive, negative, positive. Our u is sine x. Then we differentiate sine x, then we get the cos x. Then we differentiate cos x, we get the negative sine x. Our dv is e to the power 2x. When we integrate e to the power 2x, we get e to the power 2x over 2. We integrate what we got, then we get e to the power 2x over 4. Then since we have obtained the common function as the first row, we're gonna stop here. Then from here we're gonna multiply diagonally to get our terms. Our first term will be e to the power 2x over 2 times sine x. Then our next term will be negative sign. The reason being is that we have a negative sign and a positive sign. A negative and a positive sign give us a negative sign. Then we're gonna have the negative e to the power 2x over 4 times cos x. Then from here we just plug everything on our formula. We're gonna have the integral of e to the power 2x sine x dx is equals to e to the power 2x over 2 times sine x minus e to the power 2x over 4 times cos x. None of the function on the last row is equals to 0, which means we have the integral value. Our integral value is negative integral e to the power 2x over 4 times sine x dx. We take the integral on the other side, then we'll be left with a 5 over 4. The integral of e to the power 2x sine x dx is equals to e to the power 2x over 2 times sine x minus e to the power 2x over 4 times cos x. We multiply both sides by the reciprocal of 5 over 4. Then we are left with the integral of e to the power 2x as sine x dx will be equal to 4 over 5 into 1 over 2 e to the power 2x times sine x minus 1 over 4 e to the power 2x times cos x, close brackets. Then from here we just do a simple mathematics. We multiply everything inside the brackets with 4 over 5. Then we get 2 over 5 e to the power 2x times sine x minus 1 over 5 e to the power 2x times cos x. Then from here we have a common factor. Our common factor is 1 over 5 e to the power 2x. We take it outside, then we are left with okay, so we are left with 2 sine x minus cos x plus c. This is our final answer.